Welcome, soil conservation and management students, to our session 14 lecture series on global navigation satellite systems and geographic information systems. This lecture, session 14, is based off of a course at the Royal University of Agriculture in Phnom Penh, Cambodia. And I am Dr. Jared D. Williams with Brigham Young University, Idaho. I'm a professor of crop and soil science and a guest lecturer or a visiting professor at Royal University of Agriculture. This lecture will be broken down into into 5 different video lectures as listed here. Introduction to Global Navigational Satellite Systems, how global navigational satellite systems work, how GNSS segments, GNSS error, source, and correction, and then an introduction to geographic information systems, also known as GIS. Okay, with that, let's first talk about why in a soil conservation and management class we would talk about global navigational satellite systems, also known to a lot of the world as GPS. Let me write that on here. A lot of people will refer to a GNS, a Global Navigation Satellite System, as a GPS, and that's because that is the American, the USA version of a GNSS, and it was the first released and the first commonly used throughout the world. So a lot of us know that system as GPS, but it's the same thing. Okay? So what are some of the reasons why we would be interested in studying about GNS and GIS in a soil conservation and management class? Well, I have some points here that kind of explain why we would do that. First, we have some definitions for GNSS and GIS. Okay, there for you. There's the G, the I, and the S for Geographic Information Systems, or GIS, and then GNSS there for acronym. Okay. Here I have 5 reasons that I listed, and there are many more than these 5 that I have, but these are the 4 that I listed. And so one of the things that a GNSS does is it allows us to collect what we call spatial data. What we mean by spatial data is that we can go out and collect data. So if this were our field, okay, we can go out and collect a data point here, and it's going to have its positional information. Its position information, meaning, okay, that it's going to have its it could be its longitude and latitude. Okay, so not only do we collect data at this point, but we also assign it its location. Position or its location, okay, and so that's what we call, it allows for spatial data collection. Spatial meaning that we collect data and we know where it came from, where in the field or where on the earth that it came from. Now the power of being able to collect data or collect spatial data is that we can then identify site-specific soil crop needs. Okay, so for example, in a normal practice, we would sample this field. I'll put dots here to represent sampling the field. So we sample the field, and then we would average those samples together and apply fertilizer, apply lime at a single rate across the field. But we know that some areas of the field, let's for example talk about pH or pH, some areas of the field are going to have a lower pH and some might have a higher pH. Some areas may need more lime and some areas less lime. But if we apply the same rate of lime across the entire field, that means some areas will be over-applied, some will be under-applied. And so by coming out here and sampling and knowing each of these locations, we can then change. Okay, we can identify the site-specific need in the field for nutrients, and then apply, our third point here, then apply fertilizers and soil amendments at different rates across the field to meet the different needs of the crop. Okay? This will reduce the over-application of inputs, which will improve soil quality. Okay? These systems also increase our ability to manage the fields and to manage things so that we're managing things with more precision, and therefore we are applying less, or not, well, hopefully applying less chemicals and avoiding applying fertilizers. Again, here's an example of what we just talked about, where we collect data collection. Okay, so we go out here, a soil map. Okay, followed by our crop condition map and a soil condition map and our yield map. So we have several maps that we create, okay, from data like I showed here. Then we put those into a system, into our computer, and we create what we call a treatment map here. And then we're able to go out to the field and use this treatment map with GPS or GNSS on the tractor to apply that material at the rates needed for the different areas of the field. Okay? So now that we understand why a GPS system would be beneficial to us as far as understanding how it benefits our let me move my picture here, how it might benefit soil conservation and management. Okay, and let's talk about what a GNSS is. Again, it's what we call a global navigational system, and what we have right there. And this is obviously satellites in the word, so it's a satellite-based locating and navigating utility. You can see a picture here of the satellites, and there's one satellite, but there would be many satellites and the signal coming from it. Okay, so GNSS receivers take in data from these satellites. We call it constellation. A constellation referring to all the satellites up there, okay, orbiting the Earth, and then use that to identify our location. Again, I mentioned earlier the original GNSS system that most of us are familiar with is called GPS, but that GPS is a specific system developed by the United States of America, although available to everybody. I use GPS here in Cambodia. I've used GPS in Africa when I've been in Africa, and in Europe, in South America when I've been in South America as well. Okay? Even when I was out in the Pacific in Samoa. I've used GPS everywhere, and it works. Okay? So what are some of the things that we can do with GNSS or GPS? Well, it provides us our location, our latitude and our longitude. Okay? It can also provide us with our altitude, or sometimes we will call this elevation. So it'll also provide us with our there should be an E there, elevation. Okay? It can calculate our speed. It can calculate the direction in which we are moving, okay? And it can do that anytime, anywhere on Earth, in any weather, 24 hours a day. Now, I will say this, inclement weather or a lot of cloud cover can make the signal or slightly less accurate, but it is still accurate and still works. Okay? Here on this slide, I have some examples of how GNSS is used in many different applications, including agriculture. You can see several YouTube links here, and you can go type those links in and go to them. Hopefully in a regular class lecture we'll be able to use some of these links, but I encourage you to watch those. They show different applications of GNSS systems in agriculture. We also use it for navigation. How many of you have used your phone to use the map to help you know where you need to go, and you want to go visit a new restaurant, so you type that into your phone and then follow your phone's direction? That's navigation. We use it for surveying, robotics. I don't think in Cambodia you have automated vehicles, but in Europe and in the United States we have vehicles that can drive themselves. Okay, and then we also use it in construction. So there's a lot of examples of how GNSS is used, and it is heavily used in some parts of the world in agriculture, including the United States. almost all operations that I do in the field, I am using GNSS with my tractor, with making maps. It has become it's become part of agriculture for me in the United States. That concludes our introduction to global navigation satellite systems and geographic information systems.